Today's notes are on real numbers, number operations, and algebraic expressions and models. We are going to start with some vocabulary. Please pause the video and copy down the following terms. Now that you have the terms filled in, we're going to go through some examples. The first vocabulary term was whole numbers. These are known as your counting numbers. So if I asked you to count to 3, you would say 0, 1, 2, 3. These are whole numbers. And we can keep on going from there. If I'm talking about integers, integers include negatives, the number 0, and positive whole numbers. So I can start with negative numbers. I also include 0, and I'm using my positive whole numbers from the first row. Rational numbers are numbers that can be written as a fraction. So I could do something like 3 over 2. They could be negative if I wanted negative 1/2. I could use 0.25 because I could rewrite that as 1/4. I could also do something like negative 3 over 1. Irrational numbers are numbers that are not rational and decimals that never repeat. For example, the square root of 2 or pi. The next question that it asks us are, how are the subsets related to each other? We want to think about if numbers overlap into multiple categories. For our 4 terms, we can say that rational numbers would include whole numbers and integers. The reason for this, as you saw in my example, I can take a whole number or an integer and put it over 1, and it is then written as a fraction. However, irrational numbers will be separate. Next, we're going to be talking about graphing numbers on a number line. What should you do to make it easier to put numbers in increasing order when you have numbers from different subsets in different forms? So we have a mix of whole numbers, fractions, decimals, and radicals. The easiest thing to do is to turn all values into decimals. However, make sure you put your final answer written in the original form. Our next example asks us to graph the following numbers on the number line: negative 2.2, 1, 1.6, 1/4, and the square root of 6. The first 3 numbers are already in decimal form, but the last 2 we need to convert. And if you know the decimal conversion, such as 1/4 is something we hear a lot, we might know that this is the same as 0.25. Something like the square root of 6, we will use our calculators for. If you plug it into your calculator, you will get a value of 2.45. So then, now that I have all 5 terms in decimal form, it is easier for me to place them on the number line. Negative 2.2 is going to be between negative 2 and negative 3. 1 is going to go exactly on the tick mark. 1.6 is going to go just over halfway between 1 and 2. 1/4 is just past 0, but I want to remember to write this in its original form, so instead of 0.25, I'm going to write it as 1/4. And the square root of 6 is just before halfway between 2 and 3. Again, we want to make sure we're writing this in its original form. So we're listing it as the square root of 6 instead of 2.45. When you're done filling in all your definitions and your number line, please turn over to the next page. The second page starts by talking about unit analysis. This is checking that the units you use make sense. To do this, you are going to eliminate the units the same in the numerator and the denominator. For example, we want to simplify the problem and use unit analysis to get the proper label. So any unit that I see in both the numerator and the denominator, such as seconds, I'm going to cross off. I also see feet in both the numerator and the denominator. They do not have to be right next to each other. I can cross off the feet in the first term with the feet in the last term. This leaves me with miles in the numerator and hours in the denominator. These are going to make up my units. To simplify the problem, I'm going to multiply all the numbers in the numerator together. So 66 times 3,600 times 1. And I'm going to put it over the numbers in the denominator. So 1 times 5,280. If I use my calculator to simplify this, it simplifies to 45, which we can rewrite as 45 over 1. I want to keep my units, so the miles is in the numerator. So miles will be in the numerator. Hours will be in the denominator. So this is 45 miles over 1 hour, or as you are used to seeing it, 45 miles per hour. See if you can pause the video and do the second example on your own. We will discuss it tomorrow in class. The next thing we talk about are numerical expressions. These are expressions that consist of numbers, operations, and grouping symbols. An example of this would be the expression, the quantity of 2 minus 3 plus 8. 2, 3, and 8 are my numbers. I have a subtraction and addition symbol for my operations, and I have parentheses for my grouping symbols. The next thing is order of operations. Order of operations are the order that you evaluate an expression, also known as PEMDAS. PEMDAS stands for parentheses, exponents, multiply, divide, add, and subtract. For multiplication and division, you're going to work left to right within the problem, the same with addition and subtraction. You're going to work left to right and do whichever operation comes first. It is important to follow the order of operations because if you don't, you could get the wrong answer. An example of this could be using the problem from below. If I didn't follow order of operations and I just completed this problem left to right, 24 minus 8 would give me 16. So then I would have 16 times 12 divided by 4. 16 times 12 would give me 192. And 192 divided by 4 would give me 48. And we can check this when we complete the problem below, but this is going to give us the wrong answer. Let's do the first example together. 24 minus 8 times 12 divided by 4. Working in my order of operations, I'm first checking for any parentheses. There are no parentheses. I'm then checking for any exponents. There are no exponents, which means I move on to multiplication and division. Remembering that I'm working from left to right tells me that I'm going to start with 8 times 12. So I have 24 minus 8 times 12 is 96. And then I still have divided by 4. Still looking for any multiplication or division. I see 96 divided by 4. I'm going to replace that with 24. And 24 minus 24, which is my only operation left, gives me 0. You can plug this into your calculator and check your solution. Let's also take a look at the example to the right. First thing I'm looking for is parentheses. So I'm going to start by simplifying 1 minus a negative 3. That gives me negative 8 plus 5. 1 minus negative 3 gives me 4. And this is cubed. The next thing on my order of operations is e for exponent. I have 4 cubed, so that'll be the next thing I simplify. Negative 8 plus 5 times 64, which is 4 cubed. I'm now looking for multiplication and division. These parentheses here indicate multiplication, so that'll be my next operation. I have negative 8 plus 5 times 64, which is 320. Which will lead me to my final answer of 312. Please try the next 2 examples on your own. We will go over them together in class. On the last page of the notes, we're looking at some more definitions and some more examples. The first is for a variable. A variable is a letter that is used to represent one or more numbers. Most often you'll see X, Y, A, or B, but it could be any letter. The next algebraic expression is similar to numerical expression from the previous page. It is a group of numbers, operations, and grouping symbols, and here's the difference, that also have at least one variable. So in this case, there's a variable X, but as you saw from above, we could also use Y, A, or B. The next vocab word is terms. That is the parts that are added or subtracted to each other. So in the expression 3x minus 2, 3x and 2 are the terms. The coefficient is the number that is multiplied by a variable in a term. So in the expression 6y, 6 would be the coefficient. Like terms are terms that have the same variable and the same exponent. So they both need to have an x, and they both need to have the same exponent. In this case, they are 2. It does not matter that one is positive and the other is negative. The constant term is a number without a variable. So in the expression 3x plus 4, 4 would be the constant. For something to be equivalent, it has to have the same value. So 1/2 and 0.5, or 2 algebraic expressions that have the same value for all of the values of their variable. So for example, 7x plus 4x is equivalent to 11x because 7 plus 4 gives you 11. In order to evaluate the expression, you want to find what the expression is worth. So for the expression x minus 4, when x equals 6, you take the 6, plug it in for the x, 6 minus 4 gives you 2. Let's go down and discuss whether or not there is a difference between negative 3 squared and the quantity negative 3 squared. There is, in fact, a difference. So we know that, yes, there's going to be a difference. Negative 3 squared is the expression negative 1 times 3 squared. This is how your calculator will read it based on order of operations. So it's really giving you negative 1 times 9, which gives you a value of negative 9. When I have negative 3 inside parentheses and it's squared, it's telling me that I have negative 3 times negative 3, which is going to give me a positive 9. So it's important that whenever you plug negative numbers inside your calculator, especially when we're squaring them, that they go inside parentheses. We're going to go through 2 more examples. One is going to be a simplify and one is evaluate. You will do the other 2 on your own. To start the simplify problem, I'm going to distribute the x to the first 2 terms in the first set of parentheses. That will give me 4x squared plus x. Then I need to distribute a negative 3. Make sure you're distributing the negative as well, which will give me negative 3x plus 6x squared. My next step would be to combine like terms, so I'm going to combine the x squared terms together. 4 plus 6 gives me 10. It stays x squared. Then I have x minus 3x. These are like terms, they have the same variable. 1 minus 3 gives me negative 2. So this is the expression 10x squared minus 2x. We're then going to go down and look at the evaluate problem. We're doing this when x is equal to negative 3 and y equals negative 1. That means in this problem, whenever you see an x, you're going to replace it with a negative 3. And whenever you see a y, you're going to replace it with a negative 1. So all I've done is recopy down the problem and replace the variables. Next, I'm going to simplify based on my orders of operations. This can become 5 times 4 times 9, as we saw above. Negative 3 squared is 9. And we have negative 2 times negative 1, which is going to turn into a positive 2. Next, I have 4 times 9, which is 36, plus 2 over negative 3. Still simplifying inside the parentheses, 36 plus 2 is going to give me 38.